All right, this is chapter 3-7, solving systems of equations by graphing. Solving systems of equations by graphing. All right, what's happening here is really simple. It looks complicated, but all you're going to be doing is graphing two equations, two or more equations on a line, on a coordinate grid, and seeing where they intersect if they do. Where they intersect is the solution. Wherever they cross, that is the solution to the system. All right, so let's graph both of these lines. All right, so let's look at it. If the first one says y equals negative 2x minus 3. So when we're graphing, this is what I want us to see. I want us to see this right away. We're going to start with the y-intercept, which is this right here, negative 3. I'm going to put a dot right there. On the y-axis, I'm going down to negative 3. That's exactly what that means. Then I'm going to deal with the slope. That's the m part of the equation. The slope says negative 2. That means I'm going to use the rise over run process and go down 2 over 1, down 2 over 1. So watch this. I'm going to go down 2 over 1, put a dot. Down 2 over 1, put a dot. All right. Now, I'm going to do it again, down 2 over 1. All right. So now what I need to do is I need some dots on the other side. So instead of going down 2 to the right 1, I'm going to go up 2 to the left 1, like that. Up 2, left 1. This is doing the opposite, reversing the opposite way. So I can get some dots on this side. Up 2 to left 1, up 2 to left 1. All right. So now I want to create a line. All right, here's the line. It's all connected now. That's the line for that equation. All right, so now let's do the other one. Let's see here. All right, so what I want to do is look at the y-intercept here. I see it's at a positive 5. So I want to put a dot right here at positive 5 on the y-axis. Then I want to follow this slope, which is 2 over 1. That means up 2 over 1, up 2 over 1, up 2 over 1. But I have a problem. It's not going to cross if I keep going up. I got to work backwards. So instead of going up 2 to the right 1, I'm going to go down 2 to the left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. And you continue that process. That is the slope. So you continue that process. Now we connect these dots. All right, that's the line for that equation. Once you connect the dots, that's it. Now, all we need to do now is look and see where these two lines intersect. So we can clearly see they intersect right here, right there. That is the solution. All right, so that ordered pair, you have to write it as x and y coordinates. That looks like it's negative 2, positive 1. Negative 2, positive 1. All right. The question is, what does negative 2, positive 1 mean? All right, so what? They crossed. Big deal. I got an X and they crossed at a spot. What does that mean? All right, so what this means is that what you just figured out was this is X and this is Y. This coordinate will work in both equations. It'll make both equations true. For instance, the first equation says y equals negative 2x minus 3. If I plug in negative 2, 1 in here, where this x is will go right here. Where this y is will go right here. It will make this a true statement. Let's look at it. Let's plug it in. If y is 1 up here, this is y is 1. I'm going to replace this y with 1. And this x is a negative 2. I'm going to put a negative 2 right here where that x is. Get it? I'm replacing it. Then this should be a true statement. All right. So 1 equals negative 2 times negative 2 minus 3. What is negative 2 times negative 2? A positive 4. Positive 4 minus 3. What is positive 4 minus 3? 1. Does it work? Yes, it does. So what we're saying is that this ordered pair here will also work in this equation. Let's do that one. Let's write it down. Y equals 2x plus 5. That means that I'm going to replace the y with 1. I'm going to replace the x with a negative 2. And I want to see if this will work also. So this is 1 equals, what is 2 times a negative 2? A negative 4. What is negative 4 plus a positive 5? A positive 1. It works again. The left side equals the right side. That means this is what this means. This is the only ordered pair in the world that will work in both of these equations. Any other ordered pair will not work in both equations. It might work in one equation, it might work in the other equations, but it won't work in both. If I select a point, let's say out here, which this particular point is 5, 2, that point, because it's not on the green line or the purple line, it won't work in either equation. Okay? The negative 2, 1 ordered pair here is the only point that will work in both. All right? Very good. All right, let's look at this equation, this system of equations with a blank graph. What do we do when we have no numbers on the graph, but yet we have to solve and graph these two equations? First of all, when I look at the two equations, I see that both of them are already in slope-intercept form, which is good. So we can start graphing right away. So let's go ahead and do that. First of all, I see that this is a positive 1. That is my y-intercept. Remember, that's the b part of the graph, y equals mx plus b. That's 1. So I know that this is the origin. So I'm going to put a 1 right. This is a line, right? That's where 1 would be. All right. So I'm going to put a dot right here to denote my y-intercept. This is my y-axis. That's 1. All right. Now I got to follow my slope. Let's look at that. Here I have a slope of 2. We know that means 2 over 1. So what I have to do is follow this and go up 2 over 1, up 2 over 1, up 2 over 1. Now I got to work backwards also. So instead of going up 2 over 1, I'm going to go down 2, back 1, down 2, back 1, down 2, back 1. So let's go ahead and connect these dots for our line. All right, that's our line for the first equation. I'm crossing at 1 on the y-axis, and I am following the slope of 2 over 1, up 2 over 1, up 2 over 1. Now, let's do the other equation. It says y equals 2x minus 3. Where do I start? I'm going to start at the minus 3, which is a negative 3. That means I need to go down. Here's my origin. I need to go down 1, 2, 3. This is a negative 3 right here. So I'm going to put my first dot right here. All right. So now I'm going to follow the slope again. Let's see what our slope is. It is still, it's the same as the other one, 2 over 1. All right. So I'm going to follow this and go up 2 over 1, 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 up 2 over 1. Still got to work backwards. So instead of going up 2, I'm going to go down 2, back 1. All right, like that. Now let's connect those points. All right, those are the points all connected. In this particular case, the two lines do not touch. They do not intersect. They are parallel. No matter how long the line is, they will always be the same distance away from each other. All right. So in this particular case, the answer is no solution. Remember, the lines have to touch in order for there to be a solution. If they did touch, that means those 2 points would work in both equations at the same time, not just in one of them. Since neither line touch, there's no number, there's no ordered pair that will work in both equations. It might work in one, it might work in the other, it might work in neither, but it will not work in both. All right. How could we have known that prior to graphing it? Simple. Look at your slopes. Let's look right here. That's what I want you to see. Let's use this. Here we go. If you notice this, my slope in both are identical. They're the same. If the slopes are the same, but we're starting at two different locations, then the two lines they'll never meet. One of the slopes have to be different in order for them to cross. Somebody have to be doing something different. All right. One line has to be going up, or maybe the other one's going down. All right. In order for them to eventually cross. But if they're both going the same direction at the same time, starting from two different spots, there's no way that they will cross each other. All right. So that was a giveaway when you see the same exact slope. All right. All right. Very good. All right. Let's look at one more. Suppose you have these two equations. They look a little different this time. The first one says y equals 2x plus 1. Let's graph that one first. First, I notice that I have a plus 1. The first equation is written in slope-intercept form, so I can quickly go ahead and graph it. The plus 1 will be right here. That's where plus 1 is. That's where positive 1 is on the y-axis. That's where 1 is. So let's follow the slope. That's a positive number. So I'm going upward at the rate of up 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Let's work backwards. Instead of going up 2, I need to go down 2, back 1, down 2, back 1, down 2, back 1. All right. Let's connect these dots. All right. That's the line for the first equation, which was this one right here. Now let's graph the second equation. This particular equation is not written in slope-intercept form. I need to redo this equation right here so that it is written in the form of y equals mx plus b, so I can clearly identify the b and the m. So I'll know where I'm going to start and how I'm going to move. If it's not in that form, then I'm not going to be able to do that. Because looking at this equation, you might think that my y-intercept is a -2 on the end because you see a -2 here, but it's not. Let's work this out. Let's get the y by itself. So what do I have to do? I need to add 3 to both sides. Why am I adding 3 to both sides? The goal here is to get the y alone. Since I want to get the y by itself, I'm going to cancel these 3's out, bring my y down. Now I can work this out on this side. What is a -2 and a +3? A +1. Look what I have now. The same thing as the first equation. Y equals 2x plus 1. That's what we graphed the first time. So what's happening here in actuality is that this line, the second equation we just worked out, is identical to the first equation. So in reality, this line is the same line as the first one. It's the exact same line. So you should be able to see both lines just like that. You see the black line, you see the red line. All right. Now, since both lines are identical, all right, the answer is a little bit different. Here you're going to see the answer is an infinite number of solutions. You might see an answer written like that, infinite number of solutions. You might see an answer that says many solutions. You might even see all solutions. In other words, whatever works in the first equation will work in the second equation because both equations are identical. All right. So either any one of those answers are correct. You'll see in your textbook, you'll see this answer, infinite number of solutions, but the answer of many solutions and all solutions also are correct. All right, because they are essentially the exact same equation. Therefore, it's the exact same line. All right, very good.